From the dawn of our species, what we know of the universe has come from what we could see, from light. Visible light for the first stargazers, ultraviolet and infrared light for the Hubble Space Telescope, microwaves and radio waves blasting from the cores of galaxies. But there are other vibrations we can't see. 100 years ago, Albert Einstein proposed his theory of general relativity. He predicted that the acceleration of massive objects would roil the fabric of space and time, sending out gravitational waves. Nobody had detected one until now. 1 billion years ago, in a distant galaxy, a pair of black holes circled each other. They spiraled inward and finally merged. The collision unleashed the energy of 1 billion trillion suns in a fraction of a second. That energy is still spreading outward in the form of gravitational waves, space-time distortions rippling across the universe at the speed of light. As a gravitational wave travels, it compresses space in one direction and stretches space in the other, like sound going sideways. This push and pull weakens with distance. The wave fades to a whisper, so faint that physicists long thought that gravitational waves would never be measured on Earth. But in Louisiana and Washington, two of the most sensitive detectors ever built have been waiting and listening. Astronomy has grown ears. This is LIGO, the Laser Interferometer Gravitational Wave Observatory. Each detector has an L-shaped antenna with arms 2.5 miles long. Inside the ends of each arm, mirrors of ultra-pure glass are isolated from the noise, heat, and vibrations of the outside world. A beam of laser light measures the separation of the mirrors. The beam is split and sent toward mirrors at the end of each arm. If the arms are precisely the same length, the returning beams cancel each other out, and LIGO's detector sees no light. But a passing gravitational wave would stretch one arm and squeeze the other. The resulting discrepancy is tiny, a fraction of the width of a proton, but enough to misalign the beams and light up the detector in a rhythmic pattern. On the 14th of September 2015, LIGO detected a flickering light and turned it into a sound wave. A chirp. It was the echo of the marriage of those two black holes, a cosmic cataclysm that happened 1 billion years ago. Hearing a gravitational wave has opened up a new kind of astronomy. For the first time, we have ears as well as eyes on the heavens, and LIGO is only the beginning. In January of 2016, the LISA Pathfinder spacecraft arrived at its destination, a spot in space 1 million miles from here, where the gravity of Earth and Sun cancel each other out. A quiet place to attempt the impossible, keeping 2 cubes of gold and platinum in perfect freefall and perfectly still. The mission is a test, groundwork for a future mission, ELISA. 3 spacecraft 1 million kilometers apart, linked with lasers, lying in wait for gravitational waves. The largest instrument ever built would be dedicated to Einstein's elusive waves. From nearby black holes to the first rumblings of the Big Bang itself. From ultimate birth to ultimate doom. Ears tuned to the invisible music of the cosmos.